Very good morning. Okay. Today's question is analysis of system of force. Okay, this is the question of engineering mechanics. In this question, we will study how free body diagram is plotted. Okay, from the given problem and how to use the Lami's theorem. The application of Lami's theorem will be studied. And this problem can be solved two methods. One is the Lami's theorem and another is the equilibrium of forces also. Okay. So first study the problem. Two smooth identical sphere of each of radius 125 mm and weight 100 Newton rest in a horizontal channel having vertical wall. This is the vertical wall and two identical spherical ball. Okay. Having same radius and weight is 100. Okay, in horizontal the distance between vertical walls of the channel is 400 mm. Okay, this is the problem. Now, okay, first we know that this is the ball and having the radius. We have to calculate, we have to create a free body diagram. Okay, just if we plot the free body diagram having the, okay, this is the same dimension. Okay, nothing difference and in this way. Okay. Now having the same dimension. Okay, first the problem first to consider the weight that will be acting vertically downwards from the center of this sphere of the both sphere. Okay, now i will I will create the vertically downwards. Okay, in this way two weights are plotted. Okay, what is the weight? How much weight? This weight is 100 Newton. Okay, both have same magnitude. Okay, now 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 what is given? The radius is given. How much it is radius? Suppose, sorry, this is, okay, if it is radius. Okay, now I take it directly so that, okay, the radius is 125 mm. Okay, now this is given. Now what I will do, what I will do here, change the color. Okay, 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 I will plot it in this way. Okay. The distance between, okay, what is the distance between these vertical walls? These vertical walls of the distance of what? If it is given, okay, no any lines of this. Okay, I just use this line. Okay, this line 400. How much? This is 400. This is 400. Okay. Now, and this become how much? This become 125 plus 125. 125 plus 125, that will be 250 mm. The distance is 250 mm. Okay, no problem. Okay. Now I have to find out theta angle. This is the theta angle. Okay. First I will give the name. Okay. First I will give the name. Here it is A. Let's suppose. Here it is B. Let's suppose C. Then triangles ABC is formed. Now, what I will do? I will do in triangle ABC. Okay. Very good. Cos. Let's suppose 30 degree. What will be AC base upon hypotenuse, AC upon AB is not okay. Now what is given? The given data is AB. How much AB? AB is 250 mm. Okay. Now I have to find out the AC. How I will find out AC? AC will be up to this distance. Okay, up to this distance. This is 400. Okay. Now from here it is 125. From here it is 125. Okay. And both is 400. So define it would be 250. Okay. Then how much it would be 150 mm. 150 mm. Okay. AC is 150 mm. Okay. I can use that value in this cos theta is equal to AC is 150 and AB is this is AB is 250 and cancel out, sorry, okay, this I will cancel out, the value will be 0.6. Okay. Now when we calculate the theta will be cos inverse 0.6 and that will be how much? 53.13 degree. Okay. Where is 30.1? This angle becomes 53.1 degree. Okay. Now I will make a triangles. Okay. Okay. Now, okay, let's see. No, this is not going to be. No. Okay, I make it simply using freehand. Okay, let it. Okay, this way. I will make it freehand. You can make. I can make this. Okay, down, and here it is. This way. Okay. Now I find this theta angle of how much? 53.13. Okay, no problem. Now this is the A, here it is A, here it is B. Okay, now it is C. Okay, now what I have to do? If it is find out, then this angle need to identify how much it is. So how I will get this the value of this angle? In triangle ABC, we can write it here. In triangle ABC, as we know that angle of triangle is 180 degree. 180 degree minus, okay, 90 plus 53.13, and that will be, this angle is ABC. This angle is ABC, means angle of B. Now it would be 36.87 degree. Okay, now it is calculated. Okay, now this angle is 36 point, okay, 36.87. Okay, now, okay, I will do that. Okay, now this is, I will plot this, make it. Okay, now when I make a triangle of this sphere, first work was to give the vertical weight, that is vertically downwards. Now, what are the different forces or the reactions acting on this sphere? This have to identify. Okay, the different reaction is in this sphere A, it is having the reaction of this horizontal surface. Okay, now this is the horizontal surface, here it is horizontal surface. Okay, reaction of A. Okay, and it is inside the vertical wall, that wall will also act in reaction to this sphere in this way. Okay, now the in sphere B, that will be reaction B of the reaction of wall in the sphere B. Okay, and contact reaction, last one is contact reaction. That contact reaction is of B to A in this way, B to A, and A to B, that is B in opposite. Okay, both are opposite to each other. Okay, there it is, opposite to each other. This way all reactions are identified. That support, that wall reaction will be acting through the center of the, all the reactions passing through the center of the sphere. This you have to know. Okay, now in this way, if I am considering here at center B, what the reactions acting, here it is. Okay, here it is, these reactions acting vertically. Sorry, I just make it. Okay, this act, okay, here, that is perpendicular. Okay, and vertically downwards, only vertically downwards weight. Okay, no issue. Okay, and the reaction of A to B, reaction of A to B, here the direction of in this way. Okay, now the next work is to find out the value. Here it is 90 degree, this is 90 degree. Okay, no problem. If we apply the Lami's theorem to this point, now the how much component of weight, one is weight, that is 100 Newton. Okay, now this is the reaction of B. Let's suppose I give some name of the wall, vertical wall. Okay, okay. Now the reaction of A to B, I give the name reaction of A. How much component? One is, just take it different colors. Okay, now one is this much, second is this much, and third one is this much. Only three components are required to apply the Lami's theorem to this particular center O, that is concurrent. Okay, concurrent. At the same point, three components are acting. Now, what is the next work? Okay, what is the next work? Now, suppose RA is one component, then applying Lami's theorem, I have to find out the angle between other two forces, that is W and RW. What are the forces? 90 degree. That's it, no problem. Now the another component is W. What are the angle of other two components? Angle of forces between other two components, RA and RW. I have to find out this value. Okay, I have to find out this value. Okay, this value, and see, this is going to centrally, not the outward of the center. This is going to the center, through the centers. Okay, I will consider it later on. Okay, now how I will find out this value? I will find out this value. Let's suppose up to this here, up to this layer, this will be 180, 180. Now only this value I need to get. Okay. Okay. And here again I can see that this is how much? This is 90 degree. Okay. Then this value will be 90 minus 36.86. How much it will be? 90 minus 36.87. How much it would be? It would be, just get this value. Okay, no problem. 90 minus 36.86. Okay, 90 minus 36.87. This would be 53.13. This value is 53.13. 53.13. Okay. Here I can write 53.13. Okay. Now total value will be how much? Total value will be 180 plus 53.13. That would be, I think this would be around 233. I just to get this value, 180, 233.13. This would be 233.13. Okay, no problem. Now completed. Three components and angle between them also I got. Okay, now next word. Apply the Lami's theorem. I will apply the Lami's theorem. Applying Lami's theorem. Okay, what I will do, if RA, applying RA, the sign of angle at the two forces, if this is RA, other two forces sine 90 degree. Okay, now W, other two forces, if it is W, other RA and RW, then sine 233.13. The angle between them is okay. Now RW angle between other two forces will be 36.87. How much? 36.87. Okay. Now how to find out RW? Sorry, I have to get the value of RA. How I will get this value? Now using these two relations I can get the value of, okay. Now next step is, now RA will be how much? W into sine 90 means 1. Now sine of 233.13. Okay, let's suppose W is 100, that is this is 1, and sine 233 is equal to something 0.79, and this is RA. If we calculate RAB, that will be 125 Newton. 125 Newton. Okay, this is the answer. Okay, you can get this RA in different methods also. What are the different methods? Second method, if you apply the second method to get the RA, how I will get this value? Let's see. If RA is acting inward, then the two component of RA will be, one is okay, this component is inside, this is RA, okay, and 36.86. okay, here I can write RA cos 36.87. okay, now here I can write RA sine 36.87. okay, these two components are, now this RA will be in this direction, our weight will be in opposite direction. Okay, and we can find out with second methods. Okay, summation of all vertical forces will be 0. Now weight minus RA cos 36 point, how much? 36.87 is equal to 0. Now RA cos 36.87 is equal to 100, and 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 RA will be 100 divided by cos 36.87. That will be definitely 125 Newton. This is the another methods I can use. Okay. Now the third method also, if we use from this point, then I need to get the value of only this angle I will get. And in this situation, two forces, one is reaction of the vertical horizontal wall and the weight, both will act opposite to each other. And in this point, if we consider only up to this point, we can get the RB acting in the A, RA acting on the B. Okay, now from here also you can, but to avoid the complexity, I use from that point. Okay, this is the result. Okay, so result is 150 Newton. How much result is 120? Sorry, 125. Result is 125 Newton. The answer is 125 Newton. 125 Newton. It is required in Newton.